Testing. Testing, testing. Hey, testing, testing, testing. All right. Maybe that'll help. Testing, testing. Okay. Yeah, sorry about that. We will try. I am going to turn it down just a little. I see I'm clipping. Okay. All right. And does everybody have the repository? Not, I will paste the repository name in here. Sorry, we're glitchiness. Hi, Tim. Oh, now if only my server would respond to me. Paste that. GitHub. Okay, I'm going to go on because I'm not getting any response from the server. Okay, if people can hear me, I am going to assume that you've got a copy of the repository. Does anybody need a moment to get that repository? Here's the page for it on GitHub. Okay, I'm going to assume that people have, and I'm going to go on. All right. This is web programming. We are, if you do SWPL space debug, hang on, I am going to change the term from the profile to big. Okay. If you run SWPL debug, I notice that it now gives me a choice of what to edit here, and I pick one, and then it comes on up. There's a bit of bit rot because of the age of this demo. It will come on up, and then if I and once again I've not and I've managed to not hang on and let me fix that. You know something, I'm going to halt this and restart it. Okay. Right. Predictive. in time button. Okay, if you go ahead and open the debug file, this is a pretty typical way for a program to get started. This is a hands-on workshop. Go ahead and look at the code for the server and play while I jabber at you, and put your comments in the chat and your questions. And if you want these notes, if you will browse localhost 7777 workshop, you'll get the same page I have. This is a little expert system that plans out my talk based on the amount of time I've got. So assume everybody's running. Say so if you're not. Okay. Sweet Prolog operates a web server. There have been several web servers built or web frameworks made over the years, but there's really only one in use today, and that's what we'll talk about, and that's the so-called threaded server. And it runs as its own web server. A very typical deployment in production would be to have Apache or Nginx on the front, and then have a vhost file that was forwarding to some high port, and then the actual Prolog application would only accept from localhost. So, okay. So, large Prolog applications have a pretty kind of characteristic structure. Quite often there will be two files called debug.pl and production.pl in the directory, and when you start one of those, you start either the debug or the production environment. Those in turn will load something called load.pl. One distinct disadvantage of the way Sweet Prolog handles modules is that you aren't guaranteed a load order, and because of that, it's convenient to, with a large project, quite often, sooner or later, it's kind of going to get you that you're going to wish you knew what the load order was, or wish it was defined. So, a common thing to do is to have something called load.pl, which simply does a bunch of ensured loads, ensure loadeds on all of the other modules, and that way you know exactly what order they were loaded in. Okay, and then this morning. My apologies, folks. Okay, and then in this case, we will start up this module called Strange Loop. This was originally a workshop for Strange Loop conference, and all right. And in our case, I didn't want to start the server automatically, so start. Oh, excuse me. No, the debug will start it. So if you look in debug, you'll see that First thing we do is we check and see if if we're on a reasonable version of Sweet Prolog. Make certain we're running from the directory we think we are, in case the user started us from someplace odd. Do a little bit of setup. This is prior to 7.0 thing of making it easier to read code strings. And then we actually start the doc server, which will start the server. And that's the way we start the server here. The doc server, this is just the PL doc server. And since you can only be running one web server in a Sweet Prolog process, when you start the doc server, you've started your server. And then this is kind of a nice thing about Prolog, is that about the Sweet Prolog environment, is that oh, excuse me, is that it's easy to customize your environment and to tinker with the innards. John's been good about trying to make all of the internals of the system pretty transparent to work with. So for example, here, if you use you can open a page in a browser, and so I open the pages I need, and I even have a little tool defined for myself that will just pop open my tools for debugging. Okay, and then if I that's kind of the overall structure of the thing. Now, to actually start the server up, which is what we do in production, this is buried somewhere in the PL doc stuff for debug, but for us in but if we were in production, we'd be calling strange loop server, and then this calls this line in strangeloop.pl, and that line is just initiates the multi-threaded server. This argument, and this thing's always this thing's first argument is always going to be HTTP dispatch. Rivolanimits has an alternative called simple router, but this is the actual predicate that does the connecting of raw requests in to the handlers in the system. So this is our dispatch predicate, and almost everybody uses the stock one. Like I say, some people prefer Rivos. And then you can put a bunch of arguments in here. Those are covered in the online tutorial. So once we've done that, then all we have to do is add handlers, which is kind of nice because the handlers now will be pretty transparent. So there isn't actually anything that's going to that we're going to see that ties everything together, which gives us good kind of encapsulation. Okay. How is everybody doing out there? People following along? I don't think we need to introduce PLDoc. Ever. All right, abstract array and file paths. This was intended for a group of people with far less exposure to Prolog. So, okay, but we have everybody at this point has seen abstract file paths, yes? That was covered in the module system. And so, and one of the exercises. So, we also are going to have a similar system for handling abstract URI paths. And hoping that okay, so here we go. Here, for example, we always get one handler for we always get one abstract path for free. That abstract path is called root and just goes to slash. So if I browse root/zip, I get the message, I'm zippy. And I'll blow that up. And let's look at what's happened here. Notice this is a directive we called HTTP handler, which registers an HTTP handler, and I can either put a relative URI path, that is just the portion with the slashes, in here, or one of these abstract paths, and I then need the name of a predicate, which will be called plus one argument. That argument is a list that has a bunch of stuff in it that is the request. And then it's a good practice to use this is the options, and one useful option is ID, which allows you to assign an ID to the handler so that you can refer to the handler itself. There is a tool for getting the URI back from the handler based on the ID, and there's a predicate for that, and that will give you the ID for, or that will give you the URI to get back to this page. Now, suppose well, these abstract file paths are handy. What they do is they allow you to rearrange your URIs however you want, without having to go through and find every handler in the system and manually change it. just by changing these lines. So, for example, suppose as part of my application, I serve a bunch of files. So I would like to have some array path that is the root of where all those files are served from. Then I could just add this. This is a multi-file predicate and HTTP location, and then I just give it a the name of the abstract path. So, for example, if I was making a handler, I would start my handler files, and then maybe I could have files, documents, files, images, whatever. But for some reason, I want to have some files. But those are going to be on /f. And if I later decide to change them, that's where I'd change it. And then there are a few options allowed. One very useful one is priority. So if you have several of these set up, of course, one to be controlling. So, for example, now if we're serving a bunch of files, they probably are represented by flat files on our file system. So now I will add something to the file search path, the location of the static files. And now I can add a handler that calls serve files and uses and I pass the option prefix, which means use this handler for anything for this and anything under it in the hierarchy. So any longer URI. Okay. All right. Get back to my notes. Okay. All right. So let's go back and look at the simple handler. Yeah. Okay. If I look at the root handler, in this case I didn't use an abstract path, I just used an absolute path. Are people following along? Is this good? Am I being incoherent? Then my handler, which will get called to, of course, with one extra argument, is say something, and because I'm serving at the root, that's always a place where people might always be sticking stuff. I have upped my priority to make certain that it's me. Great. Okay, so now I've got this handler, say something. All right, when you are inside of a handler, notice that I'm going to get what to say, right? This was called with an argument. And then I'm going to get the request, which in this case I don't need. But when I'm inside of a handler, current input and current output are bound to the socket. So this is the crudest way and simplest way of writing out an HTTP response, is to just directly write the thing with format statements. So HTTP 1.1 requires this header This is the only required header, is the content type. And then 2 new lines to end the headers and the body. And that's just the HTTP protocol. That's how it is. And then we will print what? World. And so since we up here we said hello, this is going to say hello world. And sure as a world, this is what we say. Okay? Now let's look at goodbye. We've made another handler, and we needed another handler with just some different static options. Goodbye rather than hello. And so we could reuse our code here, and I say goodbye, then I get goodbye world. And all right. So now the howdy handlers. All right. Okay. I have also, we want to be internationalized. So I've got hello in German, and I've got hello in Kansan, howdy world, and I've got hello in a bunch of other languages. And so how did I make all these? Well, I have this predicate howdy handlers at the bottom of simple handlers, and I get what hello is in that language, hello and the URL and the language. I URL encode the language because you need the URL encode portions of an URI. I format that into /hello and the language, and then I call HTTP handler, which, since it is a normal predicate, can be called inside something else if you want to set your handlers up some other way. And then this is actually a repeat fail loop. I will fail, and then I'll go back and get a choice point at howdy and get the next howdy. So this will set up all of the handlers. And then, of course, I want that to ultimately succeed, so it's also just in there as a fact. And then I call it at consult time, and I get all of these howdy handlers. Is that clear to everybody? Okay, we're going to do something hands-on. So I would like you to go in here and add a handler somewhere at the bottom of simple handlers to say hello to yourself. Add hello me, and just print a hello to yourself, and then see that you can run that on localhost. And I'll give folks a few minutes to do that. If folks let me know when they kind of finish doing that, I don't see you. While you're doing that, I'm going to get my own act. Hey, people done that? I'm going to go on. I'm going to assume that folks have gotten that done. And start talking about the more normal sequence. Now, the more normal sequence is, you know, let me go back here. I had one about fancy handlers. Nope. Okay. Let's look in HTML handlers, and there's something called page demo, and let's go back and we'll look at page demo. Okay, all right. Now, this page was generated by the kind of the more normal sequence for generating HTML. And that sequence is going to be the part we've seen so far. There will be an incoming HTTP request. HTTP dispatch will look at the handler definitions that we defined with HTTP handler, and then we'll call the appropriate handler predicate. The usual first thing would be to call HTTP params and to extract the parameters, and then call something called reply HTML page, which does a lot of the kind of normal setup. It'll make certain that the headers are out there, and it does a lot of other kind of convenient behind the scenes things. It takes something called termerized HTML. There is a prologue style syntax equivalent for HTML that is kind of central to the system, and we'll spend quite some time on. And here, this is a title tag. This is what goes in the head. So whatever you pass in this first argument is what goes in the head. And then whatever you pass in the second argument is what goes in the body. And almost always, and there's a way of encapsulating in this kind of DSL, this termerized HTML, and that way you do encapsulation is something called an inclusion, and almost always this would be an inclusion if this was a very complicated page. But here I just have a div and then a title and a paragraph. And so this is what we get. And here's our page. Okay. Reply HTML page will take the generated termerized HTML and will convert it to a series of HTML tokens. This will be a list of tokens, and it will apply styling to it. You can define a style for and apply it to all pages. There's actually just a default page style, and there is a or you can add, there's a version of reply HTML page with one more argument. You can add a first argument, which is the style name. The next thing that will happen is that there is a facility called Mailman. The original HTTP spec envisioned sending lots of long documents that might not be where you might want to start rendering before the document finished transmitting. Supporting that is no longer a priority, and in most circumstances, and so we've taken advantage of that, and the Mailman facility is a very cool thing that lets you generate a page out of order and say, okay, this stuff actually belongs up on the top menu, but I didn't know how many things there would be to put that number in until, like, say for example, I've got a page that does have a list of things that gets generated. Well, it's actually more convenient to know how many things you've got at the bottom, but for user interface reasons, you might want to put that number up at the top. So that'd be a typical use of Mailman, is to send that number back up to the top. And then finally, it calls something called print HTML, which makes an attempt to neatly lay out the output. Of course, there are two strategies it could use. You could try and minimize transmission bandwidth and send fairly compact HTML, or it could try and neatly lay it out and send, nice, readable, human readable HTML. Honestly, in practice, it does neither. It attempts the latter and does a rather poor job of it, but it generates the final layout, and then that will ultimately get printed to current output and become the output request. That's the sequence. Okay. Questions? Comments? Start looking at the stuff in more detail. All right. Okay. Now we're going to look at the HTML generation, and there are kind of two camps of doing this when you're generating dynamic HTML. One is to use some kind of a template. This is the method that ASP and JSP use. In fact, that alternative is available in Prolog in the form of PWP or Rivo Lanamet's simple templates. pack. But the stock system that comes with Sweet Prolog is in the camp of expressing the HTML in this kind of homo-iconic Prolog termerized HTML. Actually, since this workshop was originally made, we have added quasi-quotes, which are covered in the online web tutorial. And the quasi-quotes allow you to insert kind of normal angle bracket HTML in your page. So I acknowledge there are these two camps, and I'm mostly going to talk about the homo-iconic camp in this because it's kind of the one there's more to say about. The termerized HTML depends on a single DCG, which is HTML1, but of course it's a DCG. It gets two extra arguments, but we're going to in this case, notice I've used a backslash. This is an inclusion. So I'm looking at lots of syntax here, which just generates a page with lots of syntax, and that demonstrates lots of syntax. So lots of syntax. Okay, and if you look at the lots of syntax page, you're going to get a whole bunch of differently styled things. Okay. Now, notice I've used it, rather than trying to cram all of my code into this argument, I have said backslash syntax demo, and syntax demo is a DCG. So this is actually going to be tokenized HTML. This is going to be this series of HTML tokens. And that's going to be generated by the HTML1 DCG. This is actually a DCG built into the system. And it, in turn, takes the specialized DSL language. Okay, so in this case, I'm just going to have a whole bunch of P's. All right. If I want to make an HTML tag, all I have to do is make a compound term with the contents. If it's arity 1, then that will be the contents of the tag, the stuff between the tag and the end tag. So here I've made it a list so that I can have several things within it. A tag with compound contents, and here I've made the word compound bold. So this is an example of using a list. Here I have an arity 2 tag, and the first argument is the set of attributes, and the second argument is the contents. And so you can see this is red, and it has some rollover text in it. Notice that this is something you cannot do, which is just to put in angle bracket style tags. That doesn't generate tags, that generates this. One of the design goals of this is that you are getting syntax checking of your HTML. The syntax coloring will break if you have invalid HTML. And of course, you know, just because you're writing Prolog code here, and but as a result, no, this doesn't work. You can make an entity if you need a copyright symbol. If you do need to literally include some ugly piece of HTML, this is one way of doing it. Since this was written, the HTML quasi-quoter has been written, and the HTML quasi-quoter is actually a better way of doing this because it will continue to do some syntax checking. But yeah, if, for example, there are some ugly shims for some of the Microsoft stuff that involve writing what looks like invalid HTML, if you have to do something like that, this is a way of dealing with it. Everybody knows about format. Format is if you need to be, you know, kind of composing format type things, you can use the minus sign, the common idiom in Prolog. So give an atom a minus sign in a list, and it will take the elements of the list and use them as arguments to format. You can generate a query string this way by passing a list of name, key equal value pairs, and get a properly URL encoded link. You can get you can just encode something, URL encode something by making it by saying plus encode. This plus, by the way, is concatenation, and notice you're not in Prolog, right? This is all in some DSL. So this is a much more of a functional language, and it does evaluate arguments, and then sometimes you will need to, if you just simply use commas and multiple items, usually that works, but of course occasionally you need to not have the space between them. In which case the plus is useful. If you use, and then remember I said it can need to have this, excuse me, this ID option. We'll use, we can use location by ID to get that. And then there's special handling for class. If you pass it a list, it will appropriately include those. Okay, the last thing I'm going to talk about is inclusions. And let me see how I'm here. This was a 90-minute. This was a 90-minute workshop, I think. Okay, if you start something with a backslash, it's an inclusion, which means it's going to look for a another DCG that that it will then expand as tokenized HTML. Notice tokenized, not termerized, and include. So, okay, here's an inclusion. Well, in this case, here's an inclusion that is just two other inclusions. And so, since they're already tokenized HTML, we can just concat them. And then I define them, and they just ultimately make something. But this is insanely great, because this inclusion mechanism means you can encapsulate your HTML generation. So if you have a login form on every page, or in the corner, then, or a search box, or those kinds of web pages tend to be built up out of blocks of elements. These blocks can be built. So let's go back to here and look. Now I have so let's say we've got some kind of fancy border that's a little more complicated than what we want to do with CSS. That is somehow part of our style. So we're going to have a fancy border called Dot Madness, and then of course we have some contents in that. Well, quasi quotes were in here, okay, so here's Fancy Borders, which is in its own module, right? And fine, this takes and puts a div with some oddball style around it. And if you look here, we've got inclusion A and inclusion B in inside the Fancy Border. And I've got Dot Madness, and I've got boring. And now we're going to have one problem with this, and that is that back over here in Fancy Handlers, or excuse me, back over in the HTML handlers, notice that I passed an inclusion. Here's the problem. That's in termerized HTML. That's a little piece of termerized HTML. It's not Prolog. Prolog won't term expand it, or excuse me, won't module expand it. So, because it's just a term. As a result, when we come over here, Fancy Border is going to get backslash, what was that called? Backslash an inclusion, and it's not going to know what module to get it from. And so you have to do a bit of fancy shuffling here. There is a meta. There is a meta predicate definition called HTML meta, and then you say that your predicate has this mode, so plus, and then HTML, and then since it's a DCG, you have to add the two DCG arguments on, because this doesn't understand that it's a DCG. Is that clear to everybody? That can be one of the more confusing aspects of this. Okay, great. Seems like it's clear to people. Oh, okay. All right. So let's do a little exercise. Everybody added a hello to themselves. Let's go back and modify your hello to yourself so that it's much fancier, and use reply page, reply HTML page. So change your body of your response predicate to use reply HTML page, and first just reply with a simple HTML page that says hello and gives you a headline. And then after you've done that, in whatever the body of your page is, then go ahead and use FancyBorder and dot madness and make yourself a fancy dots around it. This is so much easier with folks who have the basics of Prolog down. Doing that, I'm going. Oh, goodness. Hey, everybody doing well on the exercise? Anybody having trouble? Say something if you aren't. If you're having issues. Hey, let's do quasi quotes. Going back here to HTML handlers, there was one last thing: an inclusion with a quasi quote, QQ. If you are getting big chunks of HTML boilerplate somewhere, you probably don't want to translate those into termerized HTML. And for that reason, this thing that was added actually just before 7, called quasi quotes, is quite useful. This is a thing we got from Scala. I think it's in a few other languages. And you say twiddle, open curly, open or bar, and then a term, and this will be the kind of quasi-quoter, and some arguments to the quasi-quoter. And then 2 OR bars, and then anything up to an OR bar and a closed curly quote is in the whatever language is defined by the quasi-quoter and is totally interpreted by that. And in the case of HTML, it actually will return you terminized HTML. Excuse me, it will actually return you one of those backslash lists of tokenized HTML. But it will pass it through the XML parser, so it will. I believe if I do something invalid here, then notice that it refuses to syntax color it. It actually is aware of the syntax. So here you've got, so this is a good way of including a bunch of boilerplate. And notice that it does, it's going to do expansions. So when this is actually generated, it will just have mep in there and the variables. Okay, mailman. Roll to the top. Serving files. Okay, well. Oops. I need to do mailman. Okay. If you bring up mailman.pl, this is a pretty common situation to be in. Remember right up at the top, I mentioned mailman. We're going to look at it in detail now. Suppose I've got a page like this. This is a pretty common situation. I want to put some summary information at the top of a page, and I don't have the summary until down at the bottom. What I will do is I will put this inclusion, HTML receive, of top stuff, where I want the top stuff to appear. And then down at the bottom, I have another inclusion. And that inclusion does also another inclusion called HTML post with the address of top stuff and some terminized HTML. So this is going to get posted up to the top. Very conveniently, there is an HTML receive mailbox called head. So if you, for example, are making an inclusion that requires some JavaScript, you can place your JavaScript down here, and your meta to include the JavaScript, and have it stuck in the head. So that can be quite convenient. And I would say that that's mostly used for kind of the edge cases. For just more normal, I need JavaScript, I need this, this thing depends on jQuery type stuff. It's better to use the resource system that we'll talk about in a moment. Okay. IDs and serving files. I've mentioned I don't know where my handler is. Okay, here we go. If you need to serve files, there is kind of a canned routine that will serve from a file system. HTTP reply from files. Serve a, you know, kind of the thing Apache does by default. Styling. All right. You can, let me, all right, I'm ready for this. You can define special styles for pages. And on the way out, I'm going to go back up to, on the way out, remember I said it passes through this styling section. And you can style the head or the body, but here we're styling the, so for example, if you always want to put some bit of legalese in your head or some tags, you know, maybe some SEO stuff, you could just do that with a head style. But here it's a body style. And this is a multi-file DCG. Remember the DCGs are really just predicates, so this is a multi-file predicate that's a DCG. And user body, and then this is the style name, and then you'll be past the body, which will actually be the body tag for the HTML. So if you do this, then you take over the responsibility, or excuse me, which is going to be the actual contents of the web page. It's not got the body tag on it. And then you take over the responsibility of making the body tag. So for example, if I always wanted to have this H1 up at the top, then with this contents, then I could do this with style, and styled. All right, so the simple web page. This page has style. It doesn't appear anywhere in the handler, but it's added by the styling. All right, and okay, that's another demo of Mailman, but I think everybody's getting Mailman, yeah? If I'm going too fast, and tell me this, like I'm bopping along through this. Handle params. All right, we're going to look at parameter handling. So far we haven't done anything with request. Request has a there's help for getting the parameters out of the request. I do suggest at some point you set a breakpoint on one of these handlers and look at the incoming request. It's a list. It's got a bunch of interesting things in it. Fairly obvious. Okay, so you pass it the request and a list. Each of these will be an argument in the parameters, and first will be bound to the value of the argument, and then there's kind of a little DSL in here. You can set a default, demand the length to be a certain size, etc., etc. And then, of course, if you don't have the required stuff, this thing's going to fail, and so you should handle the failure. Okay. So, and then and then this is a very convenient little additional piece. If you're writing something big, quite often these parameters get to be pretty repetitive, and you can declare additional additional parameters that are common by having this param2 and just saying, okay, well, you can get all of the other ones from this predicate. So that's actually really handy if you have a common set of parameters. Resource inclusion. Let me find my resource demo. Okay, everybody look at resource demo. I'm going to close a bunch of this other stuff. All right. Usually you'll start building up a whole bunch of things that depend on jQuery, and a bunch of things that depend on some CSS, and a bunch of things that depend on this resource and that resource. And when you do that, it becomes really, really useful to have a way of managing resources by name. Resource demo. Okay. All right. So more of my brilliantly executed web design skills. All right. So this page, if you look at it, if you Control U it, this page includes a couple of style sheets: grad style and special style. All right, and the way I ensure that I get the thing I need. You can imagine this being down in some DCG way down in some complicated page. It's really handy to just be able to say, hey, I need this. And especially if there are a bunch of places going to need it, to make certain that it only gets included once. Right? I've seen web pages where if you hit Control U, you see they're actually attempting to download the same file multiple times. Naughty, naughty. The browser will usually save you, but you should save yourself. Okay, so you can just say HTML requires, and in this case, give the name of a file. And if you can also just make this a name, just an atom. But then you make a directive to define what the resource is. And one very handy thing you can do is you can say virtual and then over here put an atom and have something that actually is not a file but rather a notion like jQuery, and then you could be running whatever version of jQuery you need out here. You can demand the things be you can have dependencies. You can define the MIME type of the thing to know how to make the meta, and all this just kind of gets handled. There's even a thing that's never been really developed, but there was some hope of being able to figure out when you of being able to define a thing as being or a set of things that together make another thing. So once I'm going to download most of the sub things. I will just download the bigger thing, and I don't know that ever went anywhere, but that idea is out there in the weeds somewhere. Questions about resources? Well handled in the web tutorial. I wanted to have people have a choice of ways to this. Okay, sessions. All right. Okay. You can control who gets a session and when, but basically just doing use module on library sessions is enough to get you sessions by default. So everybody who visits your website will get a session. And I think the default timeout's 5 minutes. All right, so here we have page with where I'm going to get a nick. All right, and big enough to read. Notice it calls me gentle one, and then now if I reload this thing, I'm always going to be gentle one, because the first time I did not. It's going to look in HTTP session data. It's going to look for to see if it's got a nickname for me. If it doesn't, if it does, it's just going to return it, and if not, then it's going to pick one of these and is going to assert it into the database and return it. Okay, so our corny little web page is always going to return the same name for us. Okay, so everybody else want to try that, and you'll probably get a different name, but you'll notice that you get a constant name once you've started. And if you completely exit out of Prolog and restart, you can get a different name. Okay. All right. Okay, the JavaScript handling. I'm actually not going to covering this, partly because I'm nearly out of time, and partly because I'm because this is now obsolete. This predates dicts. I would say if you're handling JavaScript, there is a quasi-quoter. For example, if you dynamically need to generate a little bit of JavaScript. If you're handling JSON, yeah, there's quasi-quoter, or there's tools to translate between dicts and JSON objects, and that's extremely easy to do and makes pushing things back and forth in JSON really easy. So almost all, kind of REST interfaces in the Prolog world work on JSON just because that's so easy to do. It'll blow out nested dicts and that kind of thing for you. Okay, that's pretty much the workshop. Do I have questions? Anybody out there? Is anybody awake at this time in the morning? I apologize for, I knew this was 90 minutes. I didn't put that in the Okay, well, thanks, folks. I think at that point then we'll wrap it up. I'm not seeing questions, so yeah. So good luck with your project, and keep cranking on projects, folks. I think that's probably the best thing we're doing at the moment, and yeah, I really love using the web framework here. It's completely sane. Okay, and with that, I think we're out. Thank you all, and I'll see you in the Slack channel and on the Moodle.